Hello everyone, so this is the class prep video for solving 2-62. So for this one, the ratios Casey wrote from part A of problem 2-58 are ratios of the lengths of corresponding sides of the two shapes. So we have these two triangles, we know that they are similar. So looking at these similar triangles below, what sides correspond? And after we identify that, we want to write the ratios for the corresponding side lengths. So first, to make this a little easier, I'm going to identify these. I'm going to say that this is A, this is B, this is C, and this is D, E, and F. So first we're going to write a similarity statement to make our lives a little easier. So triangle A, B, C is similar to, so we did A, B, and then C, so 2 ticks, 1 tick, right angle, 2, 1, right angle, so EFD. Triangle EFD. Okay, so now just from this similarity statement, we can figure out, or we can identify what the corresponding sides are. We could have done that just from looking at this, but I wanted to show you both ways. So from looking at this, we know that side AB is corresponding to EF. So AB and EF are corresponding. BC and FD, because BC is here. FD is the second pair on the left here, so FD. And then the last pair is AC and ED. And again, we can see that because AC are the first and the last, ED are the first and the last. So that's how you would write them from a congruency statement, or sorry, a similarity statement. And then the other way you could do it is just from looking at the figures. So you could see that AC corresponds to DE. So there's the right angle and the angle with 2 tick marks. AB, EF, and DF, and CB. So you can see all those up here and there as well. So next we want to write the ratios for the corresponding side lengths. So if we were to write, so we know that this corresponds to that, so we can say 15/6 is one of them from triangle ABC to triangle DEF. Then we can also say this side corresponds to that side, so 20/8. Now, if these are similar triangles, then these will end up reducing to the exact same thing. So for this one, if we divide top and bottom by 3, we would get 5/2. And this one, if we do 20 divided by 4 and 8 divided by 4, we would get 5/2 again. So since both of these are the same, we know what our dilation factor is. Next, we want to calculate the length of the hypotenuse of each triangle, and we want to find out is the ratio of the hypotenuse equal to the ratio that we found in part A? Remember that ratio was 5/2. So since we have two right triangles, we know that we can use the Pythagorean theorem. And if we were to write that for this one, we have this side, and this missing side. So we can find for that missing side, let's just call it x, by doing 15 squared plus 20 squared is equal to x squared. Now 15 squared is 225, plus 20 squared is 400, and that's equal to x squared. Simplifying this, we would get 625 is equal to x squared, and then we would square root both sides to solve for x. And we would get that x is equal to 25. So x is equal to 25. Doing the same thing with this, and we will call this side, let's call that a, or let's call it c instead. So if we have 6 squared plus 8, and that's c squared is equal to c squared. 6 squared is 36, plus 8 squared is 64, is equal to c squared. Simplifying this, we get 100 is equal to c squared. Again, square root both sides, and we get that 10 is equal to c. So 10 is, or c is equal to 10. So now we're going to ask ourselves that question is, calculate the length of the hypotenuse for each triangle, and is the ratio of the hypotenuses equal to the ratio found in part A? And that was this, the 5/2. So if we do 25 divided by 10, that does reduce to 5/2 if we divide top and bottom by 2. So that becomes 5/2. So it does equal the ratio that we found in part A. Moving to part C, we want to describe a sequence of transformations that would map one triangle onto the other. So with that, I will demonstrate it using this. So we want to describe a sequence of transformations. So the first one we can say is we translate it. The next one we can say is that we can rotate it. And we would then want to dilate it, and then from playing with this, I found that that is supposed to be 89. And then we can finish translating it, and voila, they line up on top of each other. So, backing that up, what we did first was we translated it, we rotated it, then we gave it a dilation, and then we translated it exactly to where it was supposed to be. So that's how you would solve 2-62.